Hi everyone! This is just a quick video to demonstrate the endoreduplication cycle and the mitotic cell cycle, and just to compare and contrast to make it a bit easier for you to understand in quite simple terms. So first I'll talk about the mitotic cell cycle. This is composed of your four major phases. As you already know, you've got your gap phase 1, S phase where DNA synthesis takes place, gap phase 2, and then mitosis, which is M phase, where the cell actually divides into two different cells. So this cell cycle progression through these cell cycles is controlled by these checkpoints, which are controlled by cyclin-dependent kinases. This slide just gives you a quick overview of how they actually work. So this is an inactive CDK cyclin, and when a cyclin comes and binds to the CDK inactive cyclin, it activates it. And when these cyclins are activated, that'll progress them onto the next phase of the cell cycle. So basically they're a signaling molecule which will allow the cell to know when to transfer to the next stage of the cell cycle. So these are the signals involved. So you've got CDK2 cyclin A and CDK2 cyclin E, which really just both promote this synthesis of DNA in this S phase. You've got CDK1 and a cyclin B complex, which actually stimulates the cell to go into mitosis and to start dividing. And you've got CDK4 and 6, cyclin D3 complex. And note that it's D3 now because it does change in the endocycle, and that just stimulates the new stage of the cell cycle. So now this is compared with the endocycle. So this one, as you can see, straight away there's only 3 phases and there is no M phase, so there's no dividing of that cell. You've got gap phase 1, endo G1, where you've got the extended phase of this DNA synthesis, endo S, and then you've got your endo G2, which is your gap phase 2. So the signals involved are a bit different here. You've got your CDK4 and 6 cyclin D1 now, which was a previously D3. You've got this overexpression of the CDK2 cyclin E and CDK2 cyclin A complexes, basically due to this constant endo S cycle, which is always going to be just keeping on to duplicate these chromosomes. And then you've got this P57 KIP2, where you previously had the CDK1 cyclin B. And that CDK1 cyclin B complex used to drive the cell into mitosis. But this is an inactivator of CDK1, which is going to stop that cell from going into mitosis. So this is just a slide in conclusion to show you a picture representation of the two cycles, and then to illustrate the major differences. So as you can see, the expressions of the different CDKs are at different times. There is obviously no M phase, meaning that the cells never divide in the endocycle, and that leads to their large size and polyploidy. You get this expression of P57 KIP2, which is an inhibitor which blocks this CDK1 and stops the cell from progressing into an M phase, so that's why there is no M phase. You've got this overexpression of this cyclin E and A, which is basically just stimulating this DNA synthesis. And then you've got this change from the cyclin D3 to cyclin D1. So I hope that gives you just a general overview and it's easy to understand.